Hi, I'm Eneko Lazpita, a PhD student from the ModelFLOWs group and a contributor of the ModelFLOWs app. On this video, I want to introduce you to the HOSVD algorithm, a tool that can be used for pattern detection on the model decomposition. But well, first, I want to encourage you to use the application and this tool specifically by showing you the last article we released using this algorithm on an ModelFLOWs database. On the right, you can see the different patterns we can obtain by applying this algorithm to these databases. Briefly, I also want to introduce you to the SVD, to the methodology of the singular value decomposition. First, we have the snapshot matrix M, and we decompose it in three different matrices. The left eigenvector matrix, U, the singular values, and the right eigenvector matrix, V. We can first reduce the dimensionality with the rank of this snapshot matrix, but we can go further and reduce the dimensionality of the problem and truncate by truncating a number of modes k. The left eigenvector matrix corresponds to the POD modes that identify different spatial patterns. And well, going back again to the ModelFLOWs database, here I show you how our database was obtained and how we prepared this data. On the left image, you can see a simplified urban environment where we applied numerical simulation to these two mounted obstacles that are aligned with the flow direction. From these simulations, we extract the snapshot tensor, where first we have the variables, then the 3D mesh, and finally we collect the different snapshots from the simulations. For a specific case, the values of these components can be the ones that I showed you here, and we can collect them into different groups. One spatial dimension where we collect the variables with the 3D mesh, and the temporal dimension where we have the number of snapshots. For the correct use of this algorithm, we have to calibrate by using the parameter SVD tolerance, which cuts the spectrum of the SVD and in a certain energy amplitude. We can see this in this new plot, where we have the decay of the modes, the spectrum of the energy decay of the modes, applying SVD to the database I just mentioned. And here we can select which modes we retain by introducing this tolerance SVD. And well, finally, going back again to the results we obtained when applying this algorithm to our ModelFLOWs database, here I show you the stringwise velocity patterns for the first most energetic modes in the three different regimes we analyzed in this article, that are the skimming flow, wake interference, and isolated roundness, where what we change to change this regime is the distance between the buildings. Applying this algorithm to this database, we can see that we can identify different patterns and extract some conclusions from this. For example, we can see that our flow is symmetric by the symmetry these modes show, and also that the highest intensity areas and patterns that appear in these modes are related to the vertical structures that appear in between the buildings and after them. We can also see something similar for the spanwise velocity patterns, where we also plot the 10 most energetic modes, and we can see the patterns related to this velocity component. And well, that's all from my part. Thanks for watching, and if you want more information about our group or our app, you can visit us on our web. Thank you.